Hello everybody, my name is Andrei Rumyantsov. I'm with MPI Corporation and I have Jean-Pierre Tissier from Keysight Technologies today with me. We are going to talk about absolutely cool measurements and the industry first achievement in EVM measurements at the wafer level at the exhibition floor.
Hello, so I'm Jean-Pierre Tissier from Keysight Research Labs in Santa Rosa, and I have a pleasure to work with you, Andrej, on this measurement, and we have achieved amazing results. So what we are doing today is we are measuring wideband signals, we are applying wideband signals to a distributed D-band power amplifier. So we can have a very quick view of this is the amplifier. We'll dig into details, but the idea of this amplifier and the probe tips, when we want to measure it, people will usually do as parameters, gain, and a lot of things like that. But then you will have this in a system, and now we propose the opportunity to apply wideband signals on such a device at still under probe tips and to demodulate, so to have a first idea of the capability of this device to propagate high-speed communications. And when I speak high-speed communication, I speak about 100 gigabits per second, because right now, today, we are driving this device with a 12.5 gigasample clock and 256 QAM. That gives us exactly 100 gigabits per second. So this device is driven by, the measurement is managed by the PNA with a big arbitrary wave generator to generate the modulation. Then we use, this is the block scheme of the system. We have this PNA, arbitrary wave generator, and then we have a VDI setup that we will focus later on, but that is hidden below here, that will up-convert the signal to D-band. We are running a carrier at 154 gig right now, so we'll up-convert the wideband modulation from this generator to the D-band, and then we'll use the VDI modules, input and output, to measure around the DUT, input and output of the DUT, with this special module at the inputs that is here, we'll focus on later. This module has the capability to inject S parameter or wideband signals using the same RF calibration. So we perform an RF calibration under S parameter conditions and we apply it to wideband. This is really a game changer because at these frequencies the mismatch are so important. So we take this into account, and basically from this source we DPD the source to have a good modulation, and we measure the output of the DUT. We measure, and this is what we get. This is the spectrum of modulation. So this spectrum is 20 gig wide at 156 gig carrier, and we demodulate the output, and this is what we get. We get this nice constellation that is 0.5 EVM, 0.5% EVM. So this is an incredible number, but we get this thanks to the averaging capability. We repeat a quite short sequence. We have a sequence of about 2,000 symbols. So it's not a full frame. This is clearly a component test approach. So we don't do a full frame. We just do a modulated signal that is wide enough to give us the opportunity to see if the DUT can carry such a quantity of data. And so the result is here. First time ever, we have this EVM number, such an EVM number, out of a PA at D-band, and especially on the floor of the show.
And now just let us think about it, how it is even possible to achieve such a small numbers of error vector magnitude, which are less than 0.6% at the exhibition floor, at not thermally controlled measurement environment where all people are moving around and coming in and coming out. And if you don't believe me, these are real life measurements, and Jean-Pierre can prove it.
I just turned off the biasing, yes, and I will turn it back on.
And you see the power comes in, and the constellation diagram is reconstructed. So the measurements is live. So a couple of key aspects of the entire integrated system that needs to be considered to reach this level of the measurement accuracy. Number one, this is outstanding stability of the test instrumentation provided by Keysight Technologies. Number two is the best possible integration of the system components on the wafer platform. And here I would like to drag your attention to a couple of key features of our platform we call terahertz selection. First of all is the minimum possible distance from output of the frequency extender to the input of the device under test. This distance minimizes the loss and enables us to achieve maximum possible dynamic range of the measurement signal, means that maximum possible accuracy of the measurements. Number two is stability of the measurements. Why the stability is the key? Because all the results what you can read from the constellation diagram are pre-corrected using digital pre-distortion algorithms. And if digital pre-distortion algorithms compute the coefficients, the system performance must remain stable all the time. If instrument drifts, if mechanical system components drift, the coefficients don't last anymore and your constellation diagram falls apart. So the stability of the integration parts, the stability of the contact is the key as well. And let me just demonstrate how the stable is the MPI system and integration here in the live test number 2. I will just jump up. And you see that the constellation diagram don't change. This is the hardest possible test you can do in a laboratory environment. So, yeah, this system also offers the modular integration concept, means that it's not only on the automated 200 or 300 millimeter system you can achieve this type of the measurements. We can also take exactly same configuration and bring it even on the relatively small TS25 platform from MPI and have exactly same level the measurements which we already proved at RFTech conference at Washington DC this year. Last but not least, this concept remains the same. You can switch the frequency bands very easily by removing the frequency adaptation paths, which you can see here, and switching from WR10, G band, or some other frequencies which are available now in collaboration with Keysight and VDI. So just buy the feeding modules, frequency extenders for you, and you will get excellent results like we just demonstrated here on the system.